Donc, Monsieur Kamada va nous expliquer comment 100% des matériaux qui sont utilisables sont utilisés au Japon. The floor is yours.
Thank you, Mr. Chairman. I'll be talking about recycled technology of asphalt pavement in Japan. In this presentation, as introduction, I'm gonna talk about the state of Japanese asphalt pavement recycled technology. Thank you. I will then show you the represented asphalt plants in Japan. Then I will show you a mixed design method of recycled asphalt mixture that established and generally used in Japan. Then I will show you recycled materials of base course. Finally, I'll talk about a brief conclusion and future work. First, let me mention current situation of today's Japanese asphalt pavement recycled technology. The recycle ratio of asphalt mixture reached 99.5% in 2012. In the past, waste asphalt mixture were often used as base course materials. At present, the mixing ratio of RAP used for dense graded asphalt mixture has increased. More than 60% of waste asphalt mixtures are used for asphalt mixtures containing RAP. What you see here is production of virgin and recycled asphalt mixture in recent years in Japan. You can see the ratio of recycled mixtures to the total proportion of asphalt mixtures has been increasing. The ratio was only 14% in 1992, but it exceeded 50% in 1998, and it reached 76% in 2060. The recycled asphalt mixture has already been used as a general mixture in Japan. What you see here is the mixing ratio of RAP in recycled asphalt mixture in 2016. The ratio is different among the areas. The ratio is the smallest in the Hokuriku region. It's 38.9%. Nationwide average is 50.7%. The ratio is the largest in the Kanto region. It's 61.4%. The ratio of the Tokyo and surrounding area, which is in the Kanto region and consists of Tokyo Metropolis, Saitama Prefecture, Kanagawa Prefecture, and Chiba Prefecture, is even higher. It reaches 69.1%. You can see the more RAP is used in the metropolitan area. I'm going to talking about Japanese asphalt plant. The number of Japanese asphalt plants is about 1,000, and around 90% of them can produce recycled materials. Most of them are batch type, and manufacturing capacity is mostly between 45 and 120 tons per hour. Japanese asphalt plant can be divided into three types: drum dryer method, parallel heating method, and indirect heating method. Let me mention outline of the parallel heating method and the drum dryer method. An illustration of a parallel heating method is shown on the left. The parallel heating method is the most commonly used type. Approximately 70% of all is the parallel heating method. This method uses a separate drum a dryer and drum for wrap and virgin aggregates, and uses a separate drum for drying and heating wrap. This method can eliminate the moisture of wrap and heat wrap without thermal degradation. For this type, the mixing ratio of wrap used to a dense graded asphalt mixture reaches between about 30% and 60%. An illustration of a drum dryer method is shown on the right. This method mixes wrap and virgin aggregates in the same dryer. The drum dryer method is the most capable of increasing the ratio of wrap in the recycled asphalt mixture. For this type, the ratio of wrap can reach 60% or more. It's mainly used in the Tokyo metropolitan area, but it's used only about 10% of all. I'm going about talking about mixed design method of recycled asphalt mixture. Japan Road Association issued the Manual of Pavement Recycling in 2004 and established the design method for recycled asphalt mixture. What you see is the procedure of mixed design of the recycled asphalt mixture. First, wrap are collected and subject to materials test to determine whether they can be used as recycled aggregates. Then, the amount of revisionator or virgin binder and the mixing ratio of wrap are determined. In addition, the provisional blend asphalt content, which is the central value when conducting the Marshall stability test, is determined. Finally, for the mixture determined by the aforementioned conditions, the Marshall stability test is conducted in the same manner as a virgin asphalt mixture, and optimal asphalt content is determined. Let me mention about sampling of wrap and criteria of materials. The representative wrap and virgin aggregates are sampled from storage press. The extraction test and the recovery test of wrap, classified by predetermined particle size, are conducted. And the aggregate particle size and penetration or an indirect tensile coefficients are then measured. To use wrap in recycled asphalt mixture, wrap needs to be satisfied with criteria of this table. The evaluation method of indirect tensile coefficients has been developed in recent years to use more wrap containing modified asphalt. Indirect coefficient is measured by the indirect test shown in this figure. Specimens of 100% wrap are compacted and tested by the indirect tensile strength test at 20 degrees. The load speed is 50 millimeters per minute, and it measured peak load and displacement at the time when specimen is distracted. The indirect coefficient can be calculated by dividing the indirect tensile strength by the amount of displacement. The indirect tensile strength can be calculated by this formula. Let me mention about determining of mixing ratio of wrap and combined grading. Combined grading is required to adjust the mixing ratio of wrap, and the amount of additive is investigated to satisfy with quality criteria of the recycled asphalt mixture. Virgin asphalt and rejuvenators have been used as additives. New rejuvenators are rejuvenators are more commonly used. The penetration or the indirect tension coefficients have been used to determine the target design performance of the recycled asphalt mixture. This table shows the target value of recycled asphalt mixture. In general area, the largest value of penetration is between 40 and 60. The target value of indirect tensile coefficient is between 0.6 and 0.9. This table shows current criteria of rejuvenator used in Japan. Dosage rate for rejuvenators were typically about 5% to 10% by weight of the wrap binder. It will usually work out approximately 0.25% to 0.3% by weight of the total mixture. What you see here is a way of determining the additive amount of rejuvenator using penetration. The mixing ratio of wrap and combined grading are determined, and the penetration of old asphalt recovered from wrap is measured. Then the penetration is obtained by changing the additive amount of rejuvenator added in old asphalt containing wrap. The relation between the additive amount of rejuvenator and penetration is obtained. The additive amount of rejuvenator, which is the designed penetration, is determined. Afterward, the Marshall stability test is conducted on specimens to which new asphalt is added. This figure shows a way to determine the additive amount of rejuvenator using the indirect tensile coefficient. Using reference such as past records or optimal asphalt contents of virgin asphalt mixtures, the mixing ratio of wrap and combined grading are determined as well as provisional asphalt content. Specimens in which the additive amount of rejuvenator is changed are produced and the indirect tensile test is conducted. The relationship between the additive amount of rejuvenator and the indirect tensile coefficient is obtained. The additive amount of rejuvenator, which is designed indirect tensile coefficient, is determined. Afterwards, the Marshall stability test is conducted. I'm going to explain the mix design method of recycled asphalt mixtures. The Marshall stability test is generally conducted for the design of asphalt mixture in Japan. The recycled asphalt mixture, which consists of wrap, additives, virgin aggregates, and asphalt, is also evaluated by the Marshall stability test. The procedure is the same as virgin asphalt mixture. Blend asphalt content of test specimen is centered on the provisional asphalt content and changed every 0.5% when the Marshall stability test is conducted. This table shows criteria of the Marshall stability test for the dense grade mixture in Japan. The optimal asphalt content is determined, which are range where all target values are satisfied. This method and criteria is the same testing virgin asphalt mixture. If the recycled asphalt mixture is satisfied with these criteria, it is evaluated as equivalent to a virgin mixture.
I propose you finish your presentation, please.
Okay. Sorry. Base cost materials, recycled base cost materials in Japan. Let me mention iron and steel slag. Iron and steel slag as used in road materials was 20.6%. Okay.
Thank you very much.
Sorry. Conclusion is this. Thank you, Chairman.
Is there one question? No? Thank you. L'orateur suivant donc, est Jean-Éric Poirier. Donc, Jean-Éric est le directeur scientifique du groupe Colas. Il est aussi l'animateur du programme national de recherche MUR, qui